Chapter 1.2, Adding and Subtracting Integers. So the vocab for today is the term that I used yesterday in Chapter 1.1, additive inverse. Two numbers whose sum is 0 are additive inverses. So think opposites. Okay, and we'll come back to this later in example 3. So what I do want to focus on is how to add integers when you have different signs, whether one is positive and one is negative, or they're both negative, or they're both positive. So this is a summary of the sign hanging at the front of the room, and you need to memorize this. So if your signs are alike, meaning they're both positive, or they're both negative, you're going to add and keep the sign that they share. If your signs are unlike, meaning you have one positive and one negative number, you're actually going to subtract and keep the sign of the number with the greatest absolute value. Just a reminder that absolute value is a distance from 0. It is shown with this symbol, these like railroad tracks. So the absolute value of -2 is 2. It's a distance from 0. So let's jump right into these examples. Example 1. Use a number line to find each sum. Now the book does use a number line, and so I will kind of go through that very quickly, but I'd really like you to memorize these rules on top of using a number line. So here I have so here's my number line. So it says I'm starting at 5. So I would first move up here and start at 5. Then it says I'm going to add -4. Well, when I have a negative, okay, that's going to be moving to the left. So I'm going to move to the left now 4 spaces. So my answer will be 1. 5 plus -4 is the same as saying 5 minus 4. Only we don't subtract anymore. So 5 plus -4 equals 1. Now these parentheses, they're here only to differentiate between the plus sign and the negative sign. If they weren't there, you would have 5 plus -4, and that gets confusing. So we use the parentheses just to separate the negative from the positive. Now, using the rules that we talked about just a moment ago, these signs are unlike. Okay, I have a positive and I have a negative. So, according to the signs unlike rule, I would subtract. 5 minus 4 equals 1. And I would keep the sign of the number with the greater absolute value. Well, the absolute value of 5 is 5. The absolute value of -4 is only 4. Well, 5 has the greater absolute value, so I would keep the positive sign. Okay, so your final answer is 1. Now I hope I haven't confused you too much by talking about subtracting and absolute value and number lines. So from now on, I'm only going to use our rules here for adding integers in order to solve problems. If the number line works better for you, that's absolutely fine. There are several examples in the book which you can follow along with, or come see me and I'll get you sorted out. But I'm just going to stick with the rules. So here we have signs alike. I have a negative and a negative. So -5 plus -2. 5 plus 2 is 7. They're both negative, so I'm going to keep the sign that they share. And it's as simple as that. Up here in example 1, just as a quick note, I wrote an equal sign with the answer to the right side. Down here I wrote it underneath. This is actually the method I prefer. Okay, write your problem and put the answer underneath. Don't forget to box your answers. All right, example 2, find each sum. So A, let's change colors. Black's boring. Orange. -18 plus -16. Again, those parentheses just to differentiate. So I see that my signs are the same. They're both negative, so I'm going to add. So I'm going to come over here to the right side of my paper as my scratch paper and add 18 plus 16. 6 plus 8 is 14. 1, 2, 3. So I get 34. They're both negative, so I keep that negative sign. So -18 plus -16 is -34. Okay, B. -23 plus 8. So I want you to kind of picture this one in your mind first. So -23, that's pretty far to the left on that number line. I'm going to add 8, which means I'm moving to the right. I'm getting closer to 0. But I'm not going to get all the way there, which is why we're going to subtract 23 minus 8. I'm going to subtract just like normal. 32 minus 8 is 5. 1 minus nothing is 1. So I have 15. But my signs are unlike, so I need the number with the greatest absolute value. The absolute value of -23 is 23. The absolute value of 8 is 8. -23 has the greater absolute value, so we're going to keep that negative sign, which made sense because I start at -23 and I'm headed towards 0 and adding that 8, but I'm not going to get there, so my answer still being negative definitely makes sense. So in examples 1 and 2, we have been adding. So let's talk about subtracting in examples 3 and 4. And from now on, subtraction no longer exists. And we started talking about that a little bit at the end of 6th grade. But subtraction is going to run out of room. Subtraction's gone. Instead, we are going to add its additive inverse or its opposite. So here's the number line, 4 minus 6. So first I start at 4. I'm going to subtract 6, which means I'm going to move this way. 1, 2, 3, 4, 5, 6, and I end up here at -2. Without a number line though, what does that look like? So instead of writing 4 minus 6, we're going to change to adding its additive inverse. So I want to change this to adding, I'm going to change colors so you see what I'm doing. Add the opposite. Well, the opposite of 6 is -6. So do you see what I did there? Instead of 4 minus 6, now I have 4 plus -6, the opposite of 6. So now my rules apply. I'm going to add, but my signs are unlike. So 4 is smaller than 6, so I'm actually going to do 6 minus 4. 6 minus 4 is 2, but I want the number with the greatest absolute value. Well, the absolute value of 4 equals 4. The absolute value of -6 equals 6. 6 is larger, so we're going to keep the negative sign. So 4 plus -6 is -2. Now, quick note, over here in example 2, for problem B, we had 23 and 8, so we did 23 minus 8 because 23 was larger. Here we have 4 plus -6, but that's 6, the absolute value, is largest, so we need to do 6 minus 4, even though it comes second in the problem. Okay, you're still going to do 6 minus 4, because it's all about those absolute values. So let's look at example number, or the second part, example 4, I guess. So -2 minus -5. So again, I want to add its additive inverse. So instead of subtracting, I'm going to change this to adding, addition. The opposite of negative 5 is positive 5. So now I have negative 2 plus 5. So again, 5 minus 2 is 3. But the absolute value of 5 is 5. The absolute value of negative 2 is 2. The positive 5 has the greater absolute value. So we're going to keep the positive, and the answer is simply 3, which you can see here on the number line. Okay, actually we do have one more example, I believe. Yep, example 5. So the temperature in Caribou, Maine was 8 degrees Fahrenheit at noon. By 10 p.m. the temperature had changed by negative 8 degrees. Find the temperature at 10 p.m. So, anytime you have a decrease, whether it is in temperature, it is in altitude, whether it's in depth, okay, if you're underwater, that is always negative. When you have an increase in any of those things, it is always positive. So, the temperature changed by negative 8 degrees, which means the temperature fell. There was a decrease. So, how do we find this? Okay, well, what do I know? I know at noon it was 8 degrees. Noon was 8 degrees. We know that the temperature changed by negative 8 degrees, and I want to find 10 p.m. So 8 degrees where I started, minus, or actually plus, negative 8 degrees of my change equals my 10 o'clock temperature. So where am I now? 8 degrees plus negative 8 degrees. I'm at 0 degrees Fahrenheit. So where I started, plus my change in temperature, 8 plus negative 8, or 8 minus 8, 0 degrees. It is 0 degrees at 10 p.m. Okay, that is it for examples. Go ahead and complete your QCs and your CYUs. If you have questions, please come ask me.